Hello friends, welcome. Friends, the Spectrum auction is on and maybe the results are going to be out soon, maybe the end of this day. Now, the results can be of two forms. If the auction gets completed or auction does not get completed, then you will have an end of day report. Like if you see the 2022 auction, we have the end of day reports in this form. So if I click a link, you'll be able to see the link here, right? So this is the form. Let it come. Yeah, so this is coming up. So this is the form, right? You will get the data, right? And then there is one more sheet which you might get if the auction gets completed today, is in this form, which I've already downloaded. This is this form, where you will have the start frequency and the end frequency and the various companies' name associated with the circles. Now, the friends, the problem is that these are in PDF documents. Because these are PDF documents, it becomes extremely difficult to process it, right? Without converting them in a format which we can analyze. So I tried to convert this PDF document because the end of day report is very easy. I'm going to show you that also. But the biggest problem that you have to deal with is this file, which will have 74. If you look at the last auction of 2022, it has 74 pages. It may not be that long this time because the number of bidders who will be interested in bidding and getting Spectrum will be pretty less. But still, it will be a bulky file to deal with. And since there are rows which are merged, columns which are merged, it becomes very difficult. So if you convert this into Excel using a standard Excel converter, you will get an Excel file which will be very complex. So I'll show you the Excel file which I had created. So this Excel file actually contains a lot of rows and columns, and there are a lot of empty data. Now this file is looking pretty clean. The reason it is looking clean is that I have manually aligned these columns. So I didn't bother about these gaps, these columns, etc. I have aligned these columns. But today in this video, I am going to demonstrate to you that how difficult it becomes to process data being shared by DOT or any other government agency in PDF format, in not Excel format or in CSV file, to convert it if you do not have the capability to use the software codes, write your own Python script. It becomes extremely difficult to deal with this data. But in this video, I'm going to show you that in spite of a fractured data which DOT provides, where the rows and columns are merged, how to step by step work with this file without having to burn your energy or getting frustrated. So that's the whole idea. You can do it in a step-by-step format and you will not commit any errors, because when you are doing manual stuff, there is a chance that you will commit huge amount of errors. But if you are going to basically use a structured way of doing it, you will not commit errors, even though the data which has been shared with you is extremely unstructured. So first is you do the conversion. Then what you do is you manually check. If you look at this particular file, you'll see that this file looks like this. I'm going to show you the file, the converted file. This is table 1. This is the way the file looks in this sheet, right? So this file, there are rows and columns, and if you see that there are some misalignment here. Can you see the misalignment? Look at this. There is a misalignment from here to here. There is a misalignment, and you go down here. There will be misalignments down below. Some of them will not. See rows and columns which are merged. You see. So what I've done is that I have selected this whole sheet, and then I have copied and broken this into two different file structure. One is a TDD and another is FDD, because both TDD and FDD will have columns which are going to be different. So you first break this sheet into two different compartments, TDD and FDD. You can easily identify. You'll find that as you go down, you'll find there will be some rows which will be TDD and there will be some rows which will be FDD. Just slice it into two pieces, copy and paste in two different sheets. After having pasted, then you have to align the columns manually. If you don't, then it will be a nightmare. And that you can do. It will take some time. It will take 5 minutes or 10 minutes. Please do that alignment, because once you don't have to fill up all these rows and columns. You don't have to. Just whatever is the data in a particular form. For example, if the data is in this form and if there is a misalignment here, Bharti is in this particular column, just copy paste and align it so that everything falls in line, right? So once having done that, when it is cleanly aligned, you can do the same thing for TDD. Then what you do is that you go to your Jupyter Notebook. So here is the Jupyter Notebook. I'm going to show you. Where is my Jupyter Notebook? Here is my Jupyter Notebook here. Now here what I have done is I have, as usual, a standard. I have created a skeleton where I have a directory. So this is the directory where I have downloaded my files. I have stored my files, and I have basically having a link to this directory. Here I'm just changing the directory and I'm printing the path. And then what you have to do is that you have to create certain dictionary in advance. What are those dictionary? Because it is very difficult to work with columns with names which are of different types, like Andhra Pradesh. Let's have AP. You don't have to deal with long names. So convert and create certain dictionary, map those names. You can do some manual inspection and see how those names are kind of formatted. Some may be misspelled. Look at those dates, because that you can do very easily by looking at your structure. So the way to do it is that you first copy upload the data. I'm going to show you how to do it automatically without having to deal with a lot of manual visual inspection. But just be with me, otherwise I lose the trail of thought and the whole video is going to become completely unstructured. So first look at this dictionary, create a dictionary, standard dictionary. Then you have to create a mapping of the band, because the bands are named like this. I prefer to basically use a very simple name. And I don't use string, I use basically integer naming. It becomes easy to process. And then I have the operators being also named in a dictionary. Bharti, Airtel, Bharti, Reliance Jio. And then the block sizes, because I need the block sizes to deal with. Now, what you can do is that you just leave the day file. So I can show you the day file also. Let me just show you the day file. What I'll do, I'll basically create another notebook here so that it becomes easy and don't disturb the notebook structure here, which is here right now. So I'll just copy all this here and I'll run it till here, right? So this is, so let me just go here and run it till here. It will become easy for me because I don't want to waste time in typing. So once I've done that, what it is doing is the day file, which is in this directory, you see, day file, which I've already converted. So I'll show you the day file. Let it open. Sometimes my computer becomes so slow that I have to change my computer. I feel sometimes very difficult to record videos with a slow computer, right? And it gets heated up when my AC is not on. I am frustrated. So this is the file, the day file, which I have converted, the PDF file into Excel. So now let me just go back to my Python Jupyter Notebook. So if I print if I just show you the data, you will find that the data is in this particular format, right? Still a lot of nonsense here, you see. So what I do is I started cleaning up the data. So I look for the service area column in the column number 1. I'm going to show you how it is done. So because if you look at the column 1, there is a service area, and why I'm choosing the service area is because I want to clip the data frame on top of it. So when I do the clipping, I say V, and then I just show you how it is done. So you'll find that the data frame will basically become clipped, and now we have this is going to become in this particular form, right? So I'm just taken out the location of the service area, and then I've done an inversion, right? So this is the situation. I have stored the data frame in this file, and then what I'm doing a standard drop columns and drop rows, which are all null, right? So there I just copy this in the new cell, and then I run this, and then I'll show you how the data frame looks now the data frame looks much cleaner than what it was earlier. Let me just take this here, and yeah. After having done that, what I will do, I will now have to deal with nulls, because if you look at there is a column which there are certain nulls here, right, which I have to deal with. So what I'm doing is I am just going to the first column and then using a lambda function converting into string, and then just comparing with nan, because when I'm doing string, then the nan will become a small n, a and n, and then I'm doing an inversion. So you'll see that how the data frame is going to look now. If I go here and then I just copy this in this particular cell and I run this, and you'll see that the data frame will look something like this, right? This is how so all the nulls also have gone. After having taken the nulls, then I will do another round of drop NA of rows or columns which are actually of nulls, because there is a column which is null, you see, unnamed 5. So I'll just simply take away this column, and then when I show you the data frame looks like something like this. Then we have only the clean columns. After you have done that, then you name the columns, because you know the column names. So I'm just simply naming the columns. And then once you name the column here, and I say paste, and I run this, and then you see that the data frame will look something like this, right? So you're with the column names. So now you have the service area, the band, the clock, round price, aggregate demand, excess demand, PW price, and the price next round. So now what you have to do is that now you do the replacement of the service dict and the band dict, right? So once you have this data in the clean form, because I don't want these long names, I want these names to be replaced by small names. So when I do this and I run this now, and you'll see that the data frame has become much more cleaner now, right? Now it is very easy. Now it is very simple to do the processing of the data, because you know that the blocks of sale is nothing but aggregate demand minus excess demand. So when you do the aggregate demand minus excess demand, you will see the blocks for sale, the number of blocks for sale, because these are all in blocks, not in megahertz. So I just copy this and I run this in a different cell, let it come, and I run this in a different cell. You'll see that, and then when I show you the data frame will look something like this, right? So the blocks for sale will be in this particular column. Why I choose to do this, and rather than basically taking it from the NIA, because I will like to follow, because there may be some changes which are taking place, some amendment, I don't want to deal with that, right? So I just want to make sure that whatever DOT gives, I will go with the data, so there is no errors. Now what I do is that I want to calculate the megahertz per cell. Now megahertz per cell can be very easy calculated, because I am basically using a list comprehension, and since I know the block sizes here, so you'll see that how easy it is to calculate megahertz per cell. And when I run this in this particular cell, you'll see that not this. Let me just see where it is. Blocks per cell. Yeah, here it is. Copy, and then Z. Okay, where is it? Sometimes it becomes very difficult, because when you are moving from one sheet to another sheet, copy Control C, and then I do Control V here, Control V, and then I run this. So you'll see that I will have a column with megahertz per cell automatically calculated. So what is this list comprehension? It is basically using a zip function, and then two columns are being called for. One is the blocks for sale, another is the band. Because why I'm needing the band? Because I have to basically do a call of the dictionary, because I have to use this band as a key for the dictionary and then multiply by the blocks, and automatically a list is created, and the list can be copied in another column which is called megahertz per cell. So once you have megahertz per cell, then you are ready with your data, right? And what you have to do is that you actually have to basically get one more thing, which is not available, which is available. What is that information? Reserve price. That information is not available. Now if you want to calculate how much price has increased, right? So I have another file here which calculates, I don't want to go to that sheet because it will take a lot of time. I'll show you how the file looks like by copying this and running this in this particular cell. So let's look at this file. because then I'll show you the data frame. The data frame will tell you the story. So if this is DF24 auction file, so here what happens is that all the information about the auction, the reserve price per block, EMD per block, block sizes, everything, and even the reserve price per block, etc., all has been copied in that particular file which I maintain. Now I can use this reserve price per block to find out what is the reference price beyond which the price is increased. So that very easily I can do. So how I can do that? I can I basically will take the I have actually dropped the auctioneer, so let me just do the auctioneer, because since I know the auctioneer is 24, so I don't need the auctioneer. See, look, this column I'm going to drop. I'm going to drop this column, Control V, and I drop it, and then I have this data frame in this form, so I don't have that column now no longer. And then now what I do a merge. So merge I do on band, because the band is the only thing which is column, which is common here, right? So if you look at the data, let me just look at both the data frame. One is, this is the data frame which is the data of the auction of 2024. Now this has got band here. Since I have band here in this data frame, which is the daily report data, so I just do a simple merge. So how do I merge it? I'm going to show you how do I merge it. So merge is the DF, right? There's this data frame and the another data frame which I just showed you. This is down below on band and how left. So I name it as DFCom. So when I run this, you will see that the data frame now looks like this. So everything has been added to this data frame. Whatever you need, the original data frame, this one, this DF. So on top of this DF, because you have everything like blocks for sale here, and then megas for sale, and then all the information is it's a very simple thing. You just merge on band and do left. Having done that, what you need now? You need to know the ratio by how much the price has increased. So just you copy this and you run this here in the cell here, and then once you run this in this particular cell, Control V, and then you run this, what you will do, you will basically see that there is another going to be data, Control C, Control V. So you will now have one column which will give the ratio to the PWP price and the reserve price. Now this ratio is showing, some ratios are showing less than 1. Why? Because this data is actually of the daily report is for 2022 and I am using the auction price of 2024, the reserve price, and that's why these numbers are not going to be correct. You can use, when the daily report, the new daily report come, it's just a template which I have created. So once the daily report come and if the format remains the same, I can run this data in no time. That is the whole purpose of this. You should always create your own structure in place, so that you can work these things pretty fast. So that's the whole point about explaining this. So this is pretty straightforward. Now the complication comes from the other file which I told you. That is the Excel sheet which is going to carry the full information on the final auction gets over. Now I am reading this FDD sheet. If you remember, I showed you the FDD sheet, FDD and TDD sheet here. Where is it? You see, this is the file. So this has got two sheets here, TDD and FDD, with so much blanks and etc. And anybody will get completely confused with so much blanks. How will you process this data in normal Excel? It's not possible. So you need Python to do it. So what I will do is I will simply copy this particular information, which is basically nothing but reading that file, and I am going to run this in the next tab. And when I run this, so this data frame I have named as DFFDD. So Control C, Control V, and I run this. So you'll find that this data frame will look very, very bad. Why there were so much nulls, and now it will be very easy. As I run this, and I'm going to show you only one because I don't have time to show two. I'm not going to show you TDD. So what I will do is I will simply use a very simple thing which I always do. I will drop rows and columns which are all null. So once I do that, you will find that the data frame will look very, very clean. So I'll just copy this and I'll run this in a different cell. You'll see that the data frame looks very clean, right? Now it's not the end of it, it's just the beginning. Now there is a problem here. The problem is that this data frame is actually not in a format which can be processed. You need to do a lot of filtering. And for that filtering, you need to follow some techniques. And let me explain to you what technique you can follow. But before that, I am doing the replacement of band dict and the service area dict, so that I don't have to deal with long names. So I'll just simply run it. Control V and run this, and then I am going to show you how the data frame looks now. Sorry, Control Z, Control C, Control V, and then I run this. So you see that the long names are all gone here, right? Now what I've done is, now I'm going to do a frequency on filtering, because the bidder column actually contains frequency. How do you know it? Because you look at this. This is the bidder column. This is the column which is the bidder. You look, there are frequencies. I want to get rid of this. So what I'm going to do is, I'm going to run this as a filter. So okay, before bidder, I have to name the columns. So I have not named the columns. Just a minute. Yeah. Where are we? Oh, I was here. I've dropped it. Oh, I actually forgot this particular step. What is this step? This step is to basically do a filtering based on this particular column, and I want to basically filter only those columns which has got digit, and rest of the columns are going to get completely eradicated. I'm going to use this as a step first before so what I'm doing is, I'm basically, just look at this, I'm running this on unnamed 14. So see, unnamed 14, and then I'm running a filter, and then I say false, this NA is equal to true. And when I run this, because this is nothing, it is simple filter, right? With a regex expression. And those people who are doing programming, they should know. But if you don't even know, you just pause the video, copy this code, okay? And then when I run this, you'll see that the data frame will look now very clean. Control V, and you'll see that all these are gone, right? Look at this. This is very, very, very clean now. Now I will name the columns, right? Name the columns, and I name the columns. Okay, and when I name the columns, Control V and name the columns, and now you'll see that Control C, Control V. See, now look how the data frame is looking now. It is becoming better, right? So after you have done that, I have already done this step. This step has already been done. Now I will basically filter the frequency. I told you there are certain frequencies which you can very easily see. So if I show you, let me do this. Let me show you if there are frequencies already. The frequency, there will be some column, some references in the bidder column with frequency. How will you know this? You run a set here. Once you do a set with the bidder column, you will find, see, look, frequency allocation. I want to get rid of this. So how do I get rid of this? I Control V, and I am basically saying that this column containing frequency, do an inversion and do a filtering. So once I done that, what I am getting? I am getting a data frame which is now very, very clean, right? It will now contain only this information, the required information. After you have done that, you just do a reset index and drop is equal to 2, because I just don't like these indexes getting changed, right? 3, 4, 7, you see. So I'll do a reset index, and now the data frame will look quite clean from what it was earlier. Okay, see, 1, 2, 3, 4, now 0, 1, 2, 3, 4. So now what I'm going to do, now I'm going to basically create that block size. So I'm going to map the block sizes to this data frame because of the dictionary which I showed you on the block size which I created here, block dict. I'm going to put that as a column. So I'm going to go down below. So here is the block size. So I'm just going to copy this line. This is again a list comprehension. And when I run this here, you'll see Control V, and then when I copy this, Control C and Control V, you'll see the block sizes have now also been added. Why I need the block sizes? Because everything is in blocks. If I don't have the block sizes, I cannot do the frequency conversion, right? So that is the reason why. Now there will be some information here I'm going to show you in the main file, which actually contains star. right? So you will find here there will be certain frequencies which are actually having star. See, look at this, 839.0 star. This will become very difficult to process if you don't remove this. So you have to basically use again a regex expression to remove this, and you cannot just use star. You have to basically always do a slash in front of the star, because if you do star, everything will get removed. So you have to have that black backslash. If you don't use this backslash, then you will not be able to remove it. So Control V, and then I run this, then you will see that my data frame is now going to look quite clean now. So all those stars are also gone here. And now I'm going to basically calculate how much spectrum has been won, megahertz won, and which is nothing but an uplink, because the frequencies are already given there, right? So since the uplink start and uplink stop has been already given, so I do a simple vector subtraction. But if you have to convert this into float first. If you don't convert this into float, then the subtraction will not going to happen. So once you do the subtraction, you will see that the megahertz one will get calculated here. So you see how much megahertz has been won. So that is done, and then you now have to calculate the outflow. The outflow is a simple formula. What is that formula? I'm going to just paste it here and show it to you. So you say Control V. So what is this? Megahertz 1 divided by block size, right? Because you need to know how many blocks. The megahertz 1 divided by block size will give you how many blocks multiplied by the winning price per block, and then convert that into float. And then when you press enter, then you will see that Control C, Control V, you will get a bidder outflow. Now you just do group by. Suppose you want to know what is the bidder outflow for a particular operator. I'm going to show you. It is very simple to calculate. You do a group by function. And I'm going to just show you right in front of you. So group by what? Group by what you need band first, because band is important, right? You need the band. You can avoid band, you can do just bidder also. Let me show you how you can just do bidder. So if I do bidder, and then I just simply, so when I do bidder, and then what I need, bidder outflow, right? So I say bidder outflow, and then I will do sum. So once I do, if there is a problem here, I have not closed this bracket. So now you see the outflow is available. Similarly, you can do different types of group by, and you can basically get your information whatever you need. So this is important. If you don't do this, then you will struggle. You will not be able to get any information and get completely messed up. So I thought of explaining to you that how to deal with these complex data set. And if you know a little bit of hands-on coding, it becomes very easy. And then whatever you share or distribute or try to understand, it will be error-free, and you don't have to deal with unnecessary errors. Okay? Friends, thank you very much for your time. I'll come back to you with the next video next time. Thanks a lot.